All right, let's jump right in. So picture this. You're a senior multi-cloud architect. You're looking at your whole setup. You've got Kubernetes clusters spread across EKS, AKS, and GKE. They're all shared by a bunch of different teams, different projects, and there's that one big question that's probably keeping you up at night. How do you make sure they are truly, and I mean fundamentally, isolated from each other? So here's what we're going to do. We're going to walk through the blueprint to solve that exact problem. We'll start with the challenge itself, define what success actually looks like, and then we'll build our solution piece by piece, pillar by pillar, until we've got ourselves a secure fortress. You know, this is the reality for so many of us, right? Managing shared clusters is tough enough on just one cloud provider. But when you're stretching that across a multi-cloud landscape, wow, the potential for a misconfiguration, for someone to get access they shouldn't have, or for one noisy tenant to mess things up for everybody else, it just grows exponentially. I mean, that's the bottom line question, isn't it? Because if one tenant can peek into another's traffic, or if some dev workload can just go wild and eat up all the resources, then that word shared becomes a huge liability. The out-of-the-box settings, they're just not going to cut it. Okay, so how do we get from that potential chaos to a state of real, actual control? Well, the answer is all about architecting for something we call strong multi-tenancy isolation. That's going to be our North Star here. What's so important about this definition is the goal. It's not just about separating tenants. It's about making a shared environment feel completely dedicated to each and every one of them. Each tenant should be working inside their own little secure bubble, totally unaware and totally unaffected by their neighbors. That's the gold standard. In this slide, it just lays it all out, right? On the left, you've got the default state, kind of like a free-for-all where one bad app can cause a huge mess. And on the right, that's where we want to be, a structured, predictable, and secure world, where all the traffic is private, permissions are super precise, and the resources are actually guaranteed. So, how do we build it? We're going to think like a security architect who's building a fortress. And you know, every good fortress is built on a strong foundation. In our case, that foundation is made up of three fundamental pillars of Kubernetes security. First up, we have to control the traffic. Just like a fortress has controlled gates and checkpoints, we need to manage every bit of communication that flows inside our cluster. Second, we control the actions. See, it's not enough to just control who's inside the fortress. You have to control what they're allowed to do once they're in. Every action needs to be intentional and, of course, authorized. And third, we control the resources. A fortress has to manage its shared utilities, things like power and water. We've got to do the exact same thing for CPU and memory to make sure everything's fair and prevent any one tenant from causing a blackout for everybody else. All right, let's dig into our first pillar and see how this works. We're going to build the internal walls of our fortress. And this is all about creating secure, separate rooms for each tenant, using something called network policies. The easiest way to think about network policies is like a built-in firewall for your pods. See, by default in Kubernetes, any pod can talk to any other pod. It's wide open. Network policies let you flip that default from allow all to deny all, which gives you explicit, granular control over that traffic. And the strategy here is actually beautifully simple. First thing you do, you lock everything down. You put a default deny all policy on each tenant's namespace. No traffic in, no traffic out. Then, and only then, do you start poking holes and explicitly whitelisting the specific connections that you actually need, like, say, allowing traffic from the front end to the back end on port 8080. And that's it. It's a security-first approach. So our internal walls are up. Now we need a way to control who can go where and do what. That brings us to Pillar 2, issuing keycards with role-based access control, or, as you know it, RBAC. Now here's the key thing to remember. Pretty much every single action in Kubernetes, from listing pods to deleting a deployment, it all goes through the Kubernetes API. RBAC is the gatekeeper for that API. It lets you define with laser precision who is allowed to do what to which resources. And again, the logic is super straightforward. First, you create a role, which is really just a list of permissions. That's the what. For instance, a role might let a user get and list pods, but not create or delete them. Then, you use a role binding to connect that role, the what, to a specific user or service account, the who. It's simple. No keycard, no entry. Okay, our fortress has walls and it has keycards.
The last big piece is managing those shared utilities, the power, the water, to make sure no single tenant can just hog them all. This is Pillar 3, resource quotas.
You know that noisy neighbor problem we talked about? Well, this is how you solve it, directly. A resource quota lets you, the architect, set hard limits on the total amount of resources any single namespace is allowed to consume. It makes sure that one team's out-of-control process can't starve another team's mission-critical application. And you have some really fine-grained control over these utilities. You can put a cap on compute resources like CPU and memory, you can limit the total amount of storage, and you can even restrict the number of objects a tenant can create, like how many pods or services they can spin up. It's all about ensuring fairness and stopping denial of service issues before they ever happen. So let's just take a step back and look at the completed blueprint. We've taken our 3 pillars and we've put them together to construct this really comprehensive security architecture for our multi-cloud, multi-tenant setup. In this table, it just sums it all up perfectly. Network policies control the traffic, which stops any snooping. RBAC controls the actions, which prevents unauthorized changes. And resource quotas control the usage, preventing resource exhaustion. You can see how each pillar tackles a completely different threat. And look, if there's one thing to really get here, it's this. These aren't 3 separate, isolated tools. They're an integrated defense system. When you use them together, they create these layers of security that result in true, strong multi-tenancy isolation. This is how you really move from chaos to control. Ultimately, it just boils down to this. In any shared Kubernetes environment, and especially when you're working across multiple clouds, architecting for strong isolation isn't just a nice-to-have or a best practice, it is the absolute foundation that you build all your other security on top of. So, you've built these incredibly secure rooms inside your fortress, but that leads to the next big question for any architect, doesn't it? What about the perimeter? How are you going to protect the fortress itself from all the threats on the outside? That's the next layer we've got to think about.